Solving rational equations. To solve rational equations, follow these steps. 1. Find the least common denominator or the LCD. 2. Multiply both sides of the equation by the LCD. 3. Solve the equation. And 4. Check the solution. Now let us have some examples. Let us find the solution of the following rational equations. Number 1, 1 over 2x plus 3 fifths equals 1 half. For the first step, let us find the LCD. Take note, our denominators are 2x, 5, and 2. And looking at our denominators, our LCD is 10x. Second step, let us multiply both sides of the equation by the LCD. So we have 10x times a quantity of 1 over 2x plus 3 fifths equals 10x times 1 half. Third step, solve the equation. To easily solve the equation, let us multiply the LCD to each term. So we have 10x times 1 over 2x plus 10x times 3 fifths is equal to 10x times 1 half. Then let us cancel out the common factor. In our first term, 10x times 1 half, our common factor is 2x. So therefore, if we are going to cancel out 2x, we will get 5 times 1. For the second term, 10x times 3 fifths, our common factor is 5. If we are going to cancel it out, our answer will be 2x times 3. Then for our last term, which is 10x times 1 half, our common factor is 2. And if we are going to cancel out 2, our answer will be 5x times 1. Then, let us simplify by performing the operations. So we will have 5 plus 6x equals 5x. Then combining like terms, we will get 6x minus 5x is equal to negative 5. Then solving for x, we have x equals negative 5. Therefore, the computed value of x is negative 5. For our fourth step, let us check the solution. So using the original equation, 1 over 2x plus 3 fifths is equal to 1 half. First, let us replace x by negative 5. Therefore, we have 1 over 2 times negative 5 plus 3 fifths equals 1 half. Then we simplify by performing the operations. So we have 1 over negative 10 plus 3 fifths equals 1 half. Then we find the equivalent fractions, or we find the LCD of 1 over negative 10 plus 3 fifths. Therefore, we have negative 1 over 10 plus 6 tenths is equal to 1 half. Then, by simplifying it, we have 5 over 10 is equal to 1 half. And changing it to simplest form, we have 1 half is equal to 1 half. Since this is a true statement, we can say now that our solution is negative 5. Example number 2, we have 3 over x plus 1 is equal to 9 over x squared minus 3x minus 4. For our first step, we have find the LCD. But before we can find the LCD, let us find first the factors of x squared minus 3x minus 4. And the factors of it are x plus 1 and x minus 4. Now looking at our denominators, we can say that our LCD now is x plus 1 and x minus 4. For the second step, let us multiply both sides of the equation by the LCD. So we have the quantity of x plus 1 times the quantity of x minus 4 times the quantity of 3 over x plus 1 is equal to the quantity of x plus 1 times the quantity of x minus 4 times the quantity of 9 over the quantity of x plus 1 times the quantity of x minus 4. Third step, let us solve the equation. And to solve the equation, we cancel out the common factor. For our first term, our common factor here is x plus 1. And if we are going to cancel out x plus 1, our answer will be 3 times the quantity of x minus 4. For our second term, our common factors are x plus 1 and x minus 4. And if we are going to cancel it out, our answer will be 9. Next is we simplify by applying distributive property, and so we have 3x minus 12 is equal to 9. Combining like terms, we will get 3x is equal to 9 plus 12, and simplifying it, we have 3x is equal to 21. Then by applying division property of equality, our x is equal to 7. Therefore, our computed value of x is 7. For our fourth step, we have check the solution. Using the original equation, which is 3 over x plus 1 is equal to 9 over x squared minus 3x minus 4, first replace x by 7. So we have 3 over 7 plus 1 is equal to 9 over 7 squared minus 3 times 7 minus 4. Then we simplify by performing the operations, so we have 3 eighths is equal to 9 over 24. Then reducing it to its lowest term, we have 3 eighths is equal to 3 eighths. And since it is a true statement, we can say that the solution of our rational equation is 7. Example number 3, we have x over x plus 2 plus 2 over x squared plus 5x plus 6 is equal to 5 over x plus 3. First step, find the LCD. To find the LCD, first we have to find the factors of x squared plus 5x plus 6. And the factors of it are x plus 2 and x plus 3. Looking at our denominators, our LCD now is x plus 2 and x plus 3. Second step, multiply both sides of the equation by the LCD. So we have the quantity of x plus 2 times the quantity of x plus 3 times the quantity of x over x plus 2 plus 2 over the quantity of x plus 2 times the quantity of x plus 3 is equal to the quantity of x plus 2 times the quantity of x plus 3 times the quantity of 5 over x plus 3. Third step is we solve the equation. To easily solve the equation, we multiply the LCD to each term. And then, we cancel out the common factor. For our first term, our common factor here is x plus 2. And if we are going to cancel out x plus 2, our answer is x times the quantity of x plus 3. For our second term, our common factors are x plus 2 and x plus 3. And if we are going to cancel out our common factors, our answer is 2. And then for our last term, our common factor is x plus 3. If we are going to cancel out x plus 3, our answer is 5 times the quantity of x plus 2. To continue, we have x times the quantity of x plus 3 plus 2 is equal to 5 times the quantity of x plus 2. Then we simplify by applying distributive property. So we have x squared plus 3x plus 2 is equal to 5x plus 10. Then we combine like terms forming a quadratic equation. So we have x squared minus 2x minus 8 is equal to 0. Then we factor, and the factors of it are x minus 4 and x plus 2. Then we simplify by applying zero product property. And so we have x minus 4 is equal to 0 and x plus 2 is equal to 0. Then solving for x, we have x equals 4 and x is equal to negative 2. Therefore, the computed values of x are 4 and negative 2. Fourth step is check the solution. Take note, we have two computed values of x. Therefore, we have to check each of them to our original equation. And to start with, let us have x is equal to 4. Replacing x by 4 in our original equation, we have 4 over 4 plus 2 over 4 squared plus 5 times 4 plus 6 is equal to 5 over 4 plus 3. Then we simplify by performing the operations. So we have 4 over 6 plus 2 over 42 is equal to 5 over 7. Then we express them in simplest form. So we have 2/3 plus 1 over 21 is equal to 5/7. Then we find the equivalent fractions, or by getting the LCD, we have 14 over 21 plus 1 over 21 is equal to 5/7. Then simplifying it, we have 15 over 21 is equal to 5 sevenths. Reducing it to its lowest term, we have 5 sevenths is equal to 5 sevenths. And since this is a true statement, we can say that 4 is a solution. For the next computed value of x, we have negative 2. So replacing x by negative 2 in our original equation, we have 4 over negative 2 plus 2 all over negative 2 squared plus 5 times negative 2 plus 6 is equal to 5 over negative 2 plus 3. Then simplifying it by performing the operations, we have 4 over 0 plus 2 over 0 is equal to 5 over 1. Looking at our equation, it becomes undefined. Therefore, negative 2 is not a solution, and it is called extraneous solution. And looking at our computation, we can now say that the only solution of our rational equation is 4.